Hi, this is Mr. Miller, and in this video, we're going to talk about how to find the intervals where a function is increasing and decreasing. And along the way, we're going to talk about local maximum and minimum points. Another name for those is relative maximum and minimum. Okay, so here we go. We have a couple examples here. We have a beautiful function here, and I just want to talk for a second about how we kind of trace functions. When we read English, we read from left to right. We're just so used to going from left to right. That's kind of how we trace functions also. So if I look at this function, I see that it's going up in this part. It kind of turns around here and it's going down, turns around again, and it starts going up, increasing. That's what we mean by increasing and decreasing. As x gets larger, that's why we're going from left to right. As x gets larger, what's happening to y? Well, it's going up, then it's going down, and then it's going up again. All right, so that's the basic idea. First it says find the local maximums. Well, this point right here is an example of a local maximum. In order to be a local maximum, there has to be a function to the left and function to the right of it. It can't be an endpoint. And it has to be the highest point around it. It's like the peak of a hill. It's not necessarily the highest point in the whole graph, but it's certainly the highest point around it. So notice how it goes up, that's the top of the hill, and it turns around. So this local maximum is not so nice. Decimal tells me that it's approximately 3.33 and 6.74. So when we ask for a local maximum, we're asking for the coordinates of the point. All right. Well, how about local minimum? Does it have a point where it's lower than all the other points around it? And sure it does. This point right here, the function comes down, turns around, and goes back up. Okay. So it has to have function on both sides of it, and it has to be the lowest point around it. So that's a minimum. And this one is 6, 2. All right, so I'm going to erase some of the things I've added to this. And we want to talk about where's the function increasing and decreasing. Well, notice that the function is increasing until it gets to this local maximum where it turns around. Okay, so the function is kind of going up here. So we could say from minus infinity, because this function keeps going to the left, to 3.33. So we're talking about for what x values is this function going up? So until we get right here where that local maximum is. All right. It goes down and we notice like right here for these values of x, the function is going up, increasing above those. From 6 to infinity. So it's increasing in this interval or that interval, so I'm going to put a union sign to kind of connect those. All right, so this is kind of really confusing at first, I get it, but we're talking about the values of x where the function above it is increasing or decreasing. So for these values of x, the function's going up, and same for these values. Now, where is it going down? Well, again, let me erase some of this so we can see it a little bit better. It's going down right here in between the maximum and the minimum. So for these values of x right here, the function is decreasing. So we'd say from 3.33 to x equals 6. Right, so above these points, function is going down. All right, that's kind of a tough concept to get used to. Let's try it one more time. So local maximum, well, we got one here at 3, 5. So these aren't too bad to find. Local minimums, we have 2 right here. They're like the valleys, and the maximum is like the peak. So we have a local minimum at 1, 1, where the function is coming down and turns around, goes back up, and also 5, 1. All right, here we go. Where is it increasing? Well, the function is increasing right here, and it's increasing right here. Okay? It's decreasing in these other two parts. All right, so here and here, it's increasing. It's going up, up, up. So that would be from this local minimum to the maximum, 1, 3 for those values of x. All right, and it's increasing from 5, and then for the rest of its domain to the right. This function keeps going up and to the right. So from 5 to infinity. So any value of x in here or in here is where the function is increasing. So union. All right, where is it decreasing? It is decreasing right here. It's going down. So for these values of x, above those values, the function is going down. So from minus infinity to 1, and it's going down again on this piece right here, from 3 to 5 for these values of x right there. So notice we've kind of covered almost all the x-axis. The only points not included are the actual maximum and minimum themselves. But every other point, the function's either going up or down above it. And so almost the whole x-axis is covered. All right, this is a little hard to get, so hang in there. Keep trying these problems. Practice it with Desmos if you can, and you'll be fine.